Welcome to solverfy.
All right, so here we are writing an algorithm that'll find the longest word in a sentence. So first we will name our algorithm. Say longest word or something descriptive and appropriate. And the input is a sequence of symbols. Right? They're not separate. It's not a list. They're all just sort of next to each other. And for our instance, these symbols are either spaces or letters. And they'll be, say, n characters long, right? And it should be more precise that the kind of input is this string of symbols. Okay, and so we first want to be able to find the first word of our string. So let's, for an example, work with this string of symbols I've written above that just says this is a sentence. Okay, so the first thing we're going to do is if we want to represent each symbol there by a subscript I, so we'll say if AI does not equal a space, right? And of course, starting at the first one. Then we want to move on to the next element, right? So we're really just trying to find spaces to determine where our words are. So for example, we would start at the T here and say, is this a space? No. Go on to the H, is this a space? No. Is the I a space? No. Okay, and we'll go on to the fifth index here and we'll find a space. Once we hit that, that's when we'll hit our else case, okay? And once we find the space, we're going to set a variable, which we'll call longest. We're going to set that equal to all the characters we found prior to this step. So it's going to start with A1, A2, all the way up to AI minus 1. It's minus 1 because we're sitting at index 5, but we only want the characters through index 4, the T, H, I, and S. All right, so then we're going to set a few variables here. So we want to take a maximum, so the maximum I, and we'll set that equal to I minus 1. And we're doing that so that our current maximum is the length up to that point, right? So our current length of our max word is 4 because it's just index 4. So we're setting it to that, and then we're introducing an M. We're going to set that equal to I, so we're just sort of setting it equal to the space that we're currently on. And then we're going to set a K equal to I plus 1 and have it run through to N. So K is going to run through the entire sentence here. And then we're going to repeat something similar to what we did before. Okay, so we'll say, well, if a subscript K is not a space, then we want to move K up plus 1. So we'll say, just take K and set that equal to itself plus 1. So next it would hit this I and say, is that a space? No. Add 1. Is this S a space? No. And then it's going to hit in the next 8 here where we have another space. And once we hit that other space, we'll have our else if case. Okay? And what's going to happen when that case arises is we're going to take K minus 1. And we're subtracting 1 because K is at a space, but we're interested in the word itself. So we want to go back to the last letter of the word. And from that, we'll subtract M plus 1, right? Because M is at the space at the beginning of the word, and we want it to sit at the first letter of the word. And from that, we'll add 1, and that's just the way the index arithmetic works, right? So if we had a word from index 7 all the way up to 12, well, that would be a 6th letter word, but 12 minus 7 is equal to 5, right? So we need to add 1 to make that correct. Okay, then we're going to compare that to our max that we have. Let's see if I can fit it in the edge here. And so if that value is greater than the maximum, then we would need to reset our longest word. Now, in this instance, the second word is not longer, so with us, this wouldn't happen, but once we get further along in the sentence, it will. Okay, so then we need to reset our variable longest. And we're going to set it to the new word we found, which runs from a subscript m plus 1 all the way to a subscript k minus 1. And again, we add and subtract 1 for the same reasons as before, so that we're not sitting at the spaces, but at the first and last letter of the word. And then we need to reset m equal to k. So now we've moved m up to our new k, and k is going to keep going forward, right? K is running from I plus 1 to n, so k is going to tick along to index 9, and then it'll stop again at 10. It'll do the same thing where it checks to see if it's longer, and then we'll reinitialize m to this index 10 here, and then k will tick along all the way to the end here. And at the very end of it, we need to return our variable longest, which is the sequence of symbols that was the longest. Should be returning our longest word.